Lesson 3.3.1 introduces the idea of key features. Okay, so we're going to be dealing with a lot of graphs here, a lot of tables. We're going to talk about some key features of linear and exponential functions. A lot of definitions, a lot of things to read and learn in this. So make sure you're doing that. Make sure you pause this video. I'll try to explain each one individually. Most of them are fairly easy, but definitely take your time to actually read the context here. All right, so real world context that have two variables can be represented in a table or graph on a coordinate plane. There are many characteristics of functions and their graphs that can provide a great deal of information. These characteristics can be analyzed and the real world context can be better understood. Guys, you're going to be doing this all the way up through calculus, so go ahead and learn the basics of it now. Okay? So, one of the first characteristics of a graph that we can observe are the intercepts. We already talked about this. Intercepts are easy, it's nothing new. Where does it cross the x and y axis? Okay? We already know this. The y-intercept is where x equals 0. Okay? And then the x-intercept is where y is equal to 0. That's where it's crossing those axes. Alright? So, if you're trying to identify it here, you have an x-intercept at 4, 0. Okay? You have a y-intercept at 0, -8. Okay? So that is 4, 0, and 0, -8. Okay? Just quick examples of that. Alright, you do the same thing here. We have an x-intercept at 2, 0, and we have a y-intercept at 0, -3. Okay? So it doesn't matter if it's linear or exponential, you still do it the same way. Alright, another characteristic of the graphs we can observe is whether the graph of the function is increasing or decreasing. The good news for y'all currently with linear and exponential is it's always one or the other. It's either an increasing graph or a decreasing graph. It's never both, right? We'll get to some later on in the year, we'll get to quadratics that actually can be increasing for an interval and then change and be decreasing, or vice versa. But for now, stick to the easy part. Learn it when it's easy. It's always increasing or always decreasing. You'll see what I mean when we look at a graph. When determining whether the intervals are increasing or decreasing, focus just on the y values here. Okay? Think about how you read a book. You're going to read a graph the same way you read a book, which is from left to right. And what we want to do is we want to determine, as I go from left to right, are the y values increasing or are the y values decreasing? Okay? So, again, there's that idea of reading left to right and all that kind of good stuff. Alright, so take a look at it. If I read this from left to right, sometimes what I do is I'll actually put my arm right on the graph vertically, and then I'll slide my arm across. If you need to look at it, or you do it with a ruler or whatever. And what you want to do is look at how the line moves up your ruler, right? So as you go across the vertical, it's increasing, right? We're going uphill. Okay, I think that's pretty straightforward. So that is an increasing function. Okay, this one, as we go from left to right, is decreasing. Right, the further I go to the right, the more downhill I'm going to be. Pretty straightforward. Okay, the way you would write this, or one of the ways you can write this, is it's always increasing, or you can say it's increasing from -infinity to infinity. Okay, that's the interval from -infinity all the way to the left to +infinity, which is all the way to the right. Okay, get used to that interval notation here. All right, so decreasing would be the same thing. It would be from -infinity to infinity. You guys have to identify which is which. Same idea here. We have an exponential function, which over time is increasing, right? And then we have an exponential function, which over time is decreasing. Okay? An interval is a continuous series of values. Continuous means having no breaks. A function is positive on an interval if the y values are greater than 0 for all x's in that interval. Okay? Positive means above the x-axis. That's super important. Okay? Obviously, the negative is going to be below the x-axis. And you're going to start by looking for the x-intercept of the function. Okay? Again, negative is the exact same thing as before, where it's below the x-axis. Okay? And you find that by looking for the x-intercept. All right, so graphically, what we're talking about, you can see it's kind of highlighted here. We start by finding the intercept. Everything to the right of that intercept has positive y values. So this graph is positive. Okay, so it's positive when x is greater than 4. It cannot be equal to, because we're still going from left to right, so we start at 4. Okay, it cannot be equal to, because at 4 it's not positive, it's 0. 0 is not positive or negative. Okay, now when x is less than 4, okay, it's negative. Negative and positive. Okay, so we're just listing out those key features. So again, when it's left of 4, you have to go down to get to your line. Another way we could write this is negative infinity up to 4. And then this one would be 4 to positive infinity. I was right from least to greatest. Alright, so this would be then, of course, here's the example for negative is over here. Right? You have to go down to get to that function. Okay? So sorry, I did it over here. I did it over here as well, but this is the same, saying the same thing. Okay? These graphs work the same way. So starting at 2, we're going positive. Right, we're going to go up to get to our line. Okay? Our line is above the x-axis, so we're having to go up to get to it. And then on the left side, where it's negative, we're having to go down to get to that line. We're having to go below the x-axis. So x is less than 2 would be negative. X is greater than 2 would be positive. Add 2 is neither one. Alright, extrema, minimum or maximums, you'll only, for linear exponents, you only will have your relative max. That's only going to be in word problems. So we're not going to focus too hard on that, but we will talk about it briefly. Okay, it's the highest or lowest point. And then we'll come back to that in a second. So the domain of a function is the set of all inputs. We already talked about domain, right? For f of x equals 2x minus 8, the graph goes to the right of the same function, but the domain is x greater than or equal to 1. Okay? The minimum of this function would be negative 6. So in other words, if I said, 1 is the smallest value that we can plug in, because this is a real world example, then you're going to find that the y values would have to be negative 6 or greater. Because as I start plugging in 2 and 3 and 4, this will be the lowest value for y you'd ever see. So that's a relative minimum. All right, I'm going to pause this one right there.